Okay. We are ready to rumble here. Okay. Did anyone not get a formula sheet yet? Put your hands up. Everyone else has one? Cool. So those are yours to keep, right? So you can make notes on them or whatever. And then you'll get fresh ones, but exactly like it on the test, right? So that way you know what you'll have, what you won't have, right, when you're studying. So so that's always good. Okay. All right. Let's do a little tiny bit of housekeeping here. So for assignment one closed this weekend. I was getting caught up on that new course that I have, so I didn't get a chance to go through and work through your assignment ones, but remember, if it's marking you weird, then I'll go through and just manually check and adjust it later. And so don't worry, I will go through it and I will manually adjust them. So assignment one, I will manually adjust your grades. Right, but like I said, I had to wait until it closed, otherwise things keep changing on me, right? And so that's no point. And then I didn't get to it this weekend, so give me a break. No. Another thing that I was looking at, so we're slated to have labs every day until the Friday before reading break, right? Remember, we did our kind of lab one, we did in the first week so that we could have the Friday before reading break with no labs. There's also, because this term we get more labs than we did last term, and so there's only so many labs to do. So there are a couple of spare labs. I'm proposing that we use one of those spare labs for January 31st. So that's my proposal. One of the reasons is I have an appointment in Ottawa that I kind of need to go to. But also, so that's selfish, but also what we've been doing, right, is I've been kind of optimistic about how far we're getting in the class. And then we go into the lab and we're seeing stuff for the first time. So, so to kind of give myself a little buffer time, right, we'll just move the January 31st lab. Okay, and so I'll say it as a proposal for right now, and then you can contact me if you don't like that. If you really are upset about not having a lab, me using one of your spare labs, come on. So please just let me know, and I'll figure it out. But I do think it works on, well, one level for you, 2 levels for me. So, so the proposal is to use a spare lab, right? And so no lab on January 31st, which would bump us, because later after reading break, there's one lab that we can't do until we've covered some material. So scheduling was a little bit messy anyways, but I feel like I've solved it. So feels pretty good. But like I said, if you have an issue with that, let me know. We'll figure it out. Okay. All right, and I'll let you guys know on Wednesday if it go or not. All right. All right, so let's do, well, any questions before we start review? No? Ready to get your stats on? Great. We'll just do a quick review because we did a lot of math, but all we really did was we calculated the standard deviation. I showed you how to calculate the standard deviation, right? That was our main event. And so we calculated, the standard deviation. And on your formula sheet, we said that S is the square root of the sum of the xi's squared minus n times x bar squared all over n minus 1. Okay. So what we said we'd do is to calculate the standard deviation of x, right? We said, okay, well, I've got all my x's in one column here, and then I'm going to make a new column of those values squared, right? So each value squared, and then if I add those up, that would be that chunk, right? The sum of the xi's squared. I know how to find x bar. Remember, x bar is the sample mean, right? So just calculate the average. We know how to do that. Then square it, then multiply it by n. N is our sample size, right? And so, and then divide it by n minus 1, and then take the square root. So it's tedious, but it's not, once you've done it a few times, it's not hard, right? It's just, you got to sit down and break down the formula and figure out where all these things are coming from. But once you've figured it out, right, the procedure is going to be the same every time, right? And so, and we also saw how to calculate the standard deviation in Excel, right? Using the descriptive statistics, it gives us the standard deviation. And so you can definitely check your work in Excel. We also, we found the median of a data set. Oops. And I said, well, you know, we've got this kind of formula on the formula sheet. I would probably just ignore that because it is just the location of the median. Remember, the median is the value that cuts your data in half, right? So now you've got 50% below it and 50% above it, right? And so being able to find the location of the median, fine, great, but you'll still need to find what the value is, right? And so I usually just use my boop, 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 boop method. Right, and so we found the median of a data set using the boop, boop, 3 boops, it's very important, boop, boop, boop method. Patent pending, no. I should just do boop to the power of 3. Boop, boop, boop. Right, and so we found the median, right? The key thing is, well, if we want the smallest 50% below this data point and the largest 50% above it, well, that means we have to sort our data from smallest to largest first before we start counting in, right? And so that's probably the biggest mistake that I see is you forget to sort your data before you boop, boop, boop in, right? And so our data was, it was 69, 86, 74, 71, 86, 100, 68, 99, 65, and 62. I'm just going to give you the sorted values, right, because that's going to be important. The sorted values, 62, 65, 68, 69, 71, 74, 86, 86, 99, and 100. Right. We did that last day. One thing that I would want you to do, right, is once you've sorted these, just count them to make sure that you have the right number of values, right? If you're expecting to see 10 and you've only got 9, well, your numbers are all going to be wrong and it's game over. Right? So then we said, okay, to find the median, right, we just start at each end and then we boop our way in. So boop, 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 and I land on 71 and 74. So what I said we'd do is we circle those two that we land on, right? And then here, I draw a line down the middle, and that line is actually going to be our median, right? Because neither of those values are the median. So the median here is 71 plus 74 divided by 2. We just take the average of the two. And what did we decide these were? 72.5? I don't know. I don't do math, but I did remember my calculator. So 71 plus 74 divided by 2. Wow, 72.5. 72.5, right? Just for a moment, right? I guess this is the end of my review here because we didn't get this far, right? So that's where we ended last day. If we just consider the same data without the last data point, right? Without the 100, consider the same data. Oops. Without the last, without the last data point, that says data point, it doesn't look like it though. So again, I'm just going to quickly write out all these numbers, but without the last data point, right, without the 100. So I get 62, 65, 68, 69, 71, 74, 86, 86, and 99. Right. So now just to see what it looks like, right, we can find the median again. So boop, 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 boop. So now you land on one number, and so if you've circled just the one number, that is your median. Yeah. So the median is 71. Okay. So that's pretty fun. Okay. Boop, boop, boop. Yeah. You'd use Excel. Yeah. No, I'll give you a maximum of 12 values. I think the biggest one I've ever given was like 15. Still pretty manageable. You need to write them really small and keep your eyes from going cross-eyed, but that's the only problem, right? So 15, I mean, that's pretty big, but I like to stick to like between 10 and 12, somewhere around there. So don't worry, anything bigger than that, yeah, you should use Excel. Right? Excel will have a little bit more sophistication going on in the background, right? Because it's able to do kind of a weighted mean if it's kind of in the middle. And so if you get slightly different answers, especially if you're having to take the average to find your median, right? If you get slightly different answers than Excel, then that's fine, because just remember, Excel can do more things than we even want to do by hand, right? And so But in general, it should give you roughly the same answers. Okay. So we already said that we use the median as our measure of center if we have skewed data, right? So if we have non-normal data, we use the median. And the reason for that is, if we go back to our original with 100 in there, right? What if that 100 data point was something crazy like 10,000, right? Your median would stay the same, right? That 10,000 is still just one data point. So then we say, oh, yeah, skip that. Okay, one, right? So they get treated equally, right? And so that 10,000, that would be a huge outlier, right? And pulling your tail in the positive direction, right? Towards the right. I guess that's confusing. For me, it's the right. I'm showing. I'll have to do it kind of backwards for you guys, but hopefully it makes sense. Right, and so let's just summarize here. What would happen to the median if the last data point, right, was changed to 10,000? Oops. Was changed to something like 10,000, right? The key is, right, the median wouldn't change, right? The median wouldn't change. And that's true for either of these data sets. Right? One with 100 or with 99, changing the 99 to 10,000, again, it's not going to change anything. It's just one data point. So the median wouldn't change. What would happen to the mean, right? If you had to calculate the mean now, right? Well, if you had to add these all up and divide them by 10 or 9, whichever one you're working with, right? Your mean is all of a sudden going to get huge because it's being overpowered by that 10,000 data point, right? And so what would happen? What would happen to the mean? Right? The mean would get pulled in the direction of the outlier, right? Or the mean would be pulled in the direction of the extreme value, right? In the direction of the extreme value. And so that's why for non-normal data, right, we use the median as our center, because what we say, so how we summarize it, is that it's robust to outliers, right? It holds steady, it doesn't care about outliers, whereas the mean, well, what's the opposite of robust? Is flaky, is weak, no, right? And so it just kind of goes towards these extreme values, right? And so for non-normal, data, we use the median as our center, because it's more robust to outliers, because it is more robust to outliers than the mean. That doesn't mean that we can't use the median as the measure of center for a normal distribution, right? Because if we have a normal distribution, then our median and our mean are going to be the same. The reason we said we want to use the mean whenever we can, right, whenever we have a normal distribution, is because of all the calculations and the tools that we can use if we can use the mean, right? And so it doesn't mean that the median just can't be used for normal distributions. The median can be used for any distribution because it is robust, right? But the mean is always pulled in the direction of the tail, right? The mean is always pulled in the direction of the tail. So if you have a normal distribution, let's see, it's pretty good. Ish. Right. Then here, this center is the mean. Oops, clean that up a bit. But it's also going to be the median. So if you have a normal distribution, right, then the tails are symmetric, right? And so then the mean is just going to stay steady in the middle here, right? And usually we talk about the mode too. The mode isn't very interesting. The mode, remember, is just a peak, right? And so the highest point. And so if you have a normal distribution, the mean equals the median equals the mode. But I'm going to drop the mode because it's not that interesting. I'm going to focus on how the mean relates to the median. And so here, we could use either the mean or the median as our center. It doesn't matter, right? But we use the mean because it, I want to say opens up, but it introduces more powerful calculations, more powerful calculations. So if you have a distribution that kind of looks like this, right? Now this is skewed to the right, right? So this is skewed right, right? It's always skewed in the direction of the tail. And so the median would hang out kind of in the middle of that ball, right? And so the median is here. But the mean, right, gets pulled in the direction of the tail. And so the mean might be somewhere out here. And so now the median is less than the mean. How are we going to use this? If I give you the descriptive statistics of a variable, right, and it tells you that the mean is 20 and the median is 25, what should that tell you about the distribution, right? Then the mean is less than the median, right? And so from that little piece of information, we suspect that our distribution might look something like this, right? So just being able to compare the mean and the median, of course, we don't expect them to be exactly the same, right? If you have 21 and 22, depending on the spread of your data, right? Those are typically pretty similar. And so we would say, oh, they're roughly equal, so we can assume we have a normal distribution, right? Or at least a symmetric distribution. So in this case here, right, let's say the mean is somewhere down here, right, getting pulled towards in the direction of the tail, and then your median it shifts off of the mode just a little bit because there are more data points down in the direction of the tail, but not hugely, right? And so here, this would be skewed left. And that's when the mean is less than the median. Or, I mean, you could revolving door that and have the median is greater than the mean. It doesn't matter to me. Just as long as you remember that, okay, my mean is going to get pulled in the direction of the tail. Any questions about that so far? Cool. So we already kind of sort of talked about, well, for our spread, we're actually going to use the interquartile range, which means we have to talk about the quartiles. And we saw the quartiles in the lab. The quartiles, they just split our data into quarters, right? So the median splits our data in half, right? That's 2 quarters below, 2 quarters above, right? So we've already got one of the quartiles, right, Q2. But now we're going to talk about the first quartile and the third quartile. Okay? And so for non-normal distributions, we use the interquartile range. Right. Remembering that inter means between, so between quartile range, right? The distance between the quartiles. Which means we need to find the quartiles. We need to find the quartiles. The quartiles, we're going to find them the exact same way that we found the median, right? Except if I just scroll back up there for a second here, right? Either one of these. The difference is that, okay, well, the first quartile, right, is going to be the value that cuts the lowest quarter from the top 3 quarters. So it's essentially going to be the median from the minimum to the median. Right? And then the third quartile, same idea, right? From the median to the maximum, you'll be able to find it counting in. Here's the pickle. Here, this value is the median, right? Which means we can't use it to find our quartile, right? And so to find the first quartile, we would start here at 69 and 62 and count in, right? And so then the first quartile would be the average of 65 and 68. This one behaves a little bit differently, right? Because we said that the line is actually the median, right? So here, this number is the median. Here, the line is the median. So when you're counting in, then you can start at 71 and 62, right? So how you find your quartiles is going to depend on how you found your median. Okay. So I'll come back and steal those later. But to find the quartiles, we use the same method as finding the median. Right? If the median is a number, right? A number in your data set. So if the median is a number in your data set, it cannot be used to find the quartiles. It cannot be used to find the quartiles. Yeah. It's still Q2. It's just a matter of how we find Q1 and Q3. Yeah. Yeah, so it can't be used anymore because it's already been used up as the median. And so, and if the median is the average of two numbers, if the median is the average of two numbers, those numbers should be used to find your quartiles. Those numbers should be used to find your quartiles. Yeah. So now I'm going to go back and steal those two data sets where we found the medians. Maybe, oops. Come on. I wanted all of it. Copy. Actually, sure. Keep that little blurb in there. Just because I can. Yeah. So what we said was, okay, well, to find the first quartile of the first data set, right, then according to the rules that we just set out here, well, this line is the median, so now to find the first quartile here, we start at 71 and 62, and we can boop, boop, and we land on 68. So then here, this is, so our first quartile is 68. Doing the same thing with the third quartile, right? Because 68, right? We've got 25% of our data below it, right? So think quartiles, just think in quarters, right? You're breaking up your data into quarters. And so now for the third quartile, right, we want to do the same thing, but on the upper end. And so from 74 and 100, we can boop, boop, and we end up at 86, right? So then our third quartile is 86. Okay. Hey, I lost an S here, somewhere along the way. Consider. in this next data set, right, we've used the 71 as our median, and so our booping would start at 69 and 62, and so we end up taking the average of 65 and 68. 65 plus 68, just making sure, is 66.5. And so here, our first quartile is 66.5, right? The average of those two. I got lazy, I didn't write that out. Third quartile, starting at 74, 99. Our third quartile. So whenever you're drawing that line, that's where that value is. So that third quartile is easy enough. 86 plus 86 divided by 2, 86. Right. So it just depends on how you found the median. That's going to link you to how you find your quartiles. And that's going to be important because I'm 99% sure that a question like this is going to be a multiple choice question on your lab exam, right? Because this will have been early on stuff, right? And so, of course, doing it the wrong way will be an option too. So you just want to keep your wits about you, right? And remember, okay, well, if I use that value as the median, I can't use it anymore to find my quartiles. If I didn't use those exact values, right? If I drew a line, then I can use them to find the quartiles. Right? So you just want to remember that, right? But other than that, it's, I don't know, I think it's pretty fun. So, of course, we don't just write first quartile, third quartile every time. Usually we use notation, Q subscript 1 or Q1 and Q3. And so, dealing with the page break here, I'll just start here. So quartiles split our data into quarters. Right. Not so crazy. Q subscript 1 or Q1 is the first quartile. Oops. I keep wanting to combine words. Splits lowest turned into slowest. Yikes. Maybe I'm on the brink of coming up with a new language or a new writing technique. A lot of deciphering going on. Splits the lowest 25% from the largest 75% of the data. We do have Q2, but usually we just call it the median, right? So this is the second quartile equals the median, right? Because we already established, well, if you have 2 quarters below and 2 quarters above, well, then you have half of the data on either side, right? And so here, this splits the data in half. And then finally, Q3, well, that's your third quartile. Third quartile, which splits the lowest 75% from the upper 25%. Splits the lowest 75% from the upper 25% of the data. Right. Quartiles are really just percentiles, right? So in general, we can talk about percentile, especially in, you know, grades and stuff like that, weights, you know, health things. We talk about percentiles. You want to be in the top, the 10th percentile, the 90th percentile, the 95th percentile, depending on what you're talking about, right? And so here, the first quartile, well, that's the 25th percentile, right? The median is the 50th percentile. And so whatever percentile you're talking about, right, it's just going to have that percentage below that data point. Okay? And so in general, we can calculate any percentile oops, percentile by finding the value that splits the lowest, and I'll just say P%, by finding the value that splits the lowest P%, right? Any percentile, 10th percentile, 25th percentile, right? From the upper 100 minus P%. Quartiles are just specific percentiles. Quartiles are specific percentiles, right? Q1 is the 25th percentile. The median is the 50th percentile. And Q3 is the 75th percentile. Okay. So they're all the same. We're not going to focus on random percentiles, right? Excel can calculate percentiles for you, right? And so for us in the lecture, right, we're just going to talk about the quartiles, right? And so Excel can calculate any percentile, but in the lecture, we will focus on the quartiles. So I know a lot of you have worked on lab 2 already, and so you've already seen the interquartile range. It's also on your formula sheet, right? So the interquartile range we said was going to be our spread, right? Our best measure of spread for non-normal data. And so we said that for non-normal data, we use the median as our measure of spread. And the center. Yikes. Our median is our measure of center. And our interquartile range is our measure of spread. Thanks. And the interquartile range which from now on, we're just going to call IQR. As our measure of spread. I'll make sure I got that. So the interquartile range, right? Q3 is always going to be bigger than Q1. If we just want to know the distance between these two, then the interquartile range is just Q3 minus Q1, right? Third quartile minus the first quartile. So that does ignore kind of the upper and the lower 25% of the data, right? And just focuses on, well, where's the central 50% of our data, right? Between Q1 and Q3, we've got 50% of our data. Right? And so we use the interquartile range, right? And if you're looking at your formula sheet, right? There's something called the 1.5 IQR rule for outliers. Okay. So that's where we're headed. We use the interquartile range to determine if we have actual outliers. So first, let's talk a little bit about outliers. Has anyone read the book Outliers by Malcolm Gladwell? Anyways, it's really good. And it's kind of like a stats for fun read. I don't know, it's hard to explain. But I love Malcolm Gladwell, so maybe that's just me. But an outlier is just an extreme value. And so usually, right, we're pretty good at looking at something and being able to say, oh, that's kind of a weird value here, right? That's way over in the tail, something like that. Or, whoa, this value is really large or really small, right? So we're pretty good at being able to pick out what extreme values might be. Okay? But we need some rule that says because it's larger than this value, it is considered an outlier, right? Or because it's smaller than this value, right, I can consider it an outlier. So we need these kind of hardened, kind of steady rules that say, well, how can I calculate the bounds, right? Anything beyond these bounds will be considered outliers, right? Just so we're not saying, oh, well, that's an outlier, right? We need to be able to say this is an outlier because it's beyond this point, right? And so that's when we use the 1.5 IQR rule. And so to determine if our data has any outliers, we use the 1.5 IQR rule to calculate upper and lower bounds. Any values beyond these bounds are outliers. So any values beyond these bounds are outliers. Just want to see how it's set up on your, okay, kind of nasty, but oh well. On the lower end, so let's set up a lower bound. on the lower bound, the rule says that any values that are 1.5 times the interquartile range below the first quartile, I know, right? But that mathematically looks like this, right? Q1 minus 1.5 times the interquartile range. Any values beyond that point are outliers. And then our upper bound, well, now we start at Q3, right, the third quartile, and any values that are more than 1.5 times the interquartile range above Q3 are going to be considered outliers, right? So moving out from our quartiles, we move out 1.5 times the interquartile range. Anything beyond that is an outlier. So the upper bound is Q3 plus 1.5 times the interquartile range. Right. I want you to pay attention to the plus and the minus, right? But if you're just imagining your data set, right, median, and then you've got your quartiles here, well, if you want to move down from Q1, you have to go minus, right? And if you want to move up from Q3, you have to go plus, right? So these are on your formula sheet, but notice that they're written a little bit squished on your formula sheet, so you have to remember which one's which. But in general, it just gives you the bounds. Okay. So on the formula sheet, it just looks like Q3 plus 1.5 times the interquartile range, comma, Q1 minus 1.5. It's got the multiplier in there. I don't like that, but it can get confusing. So just be aware that it's not set up all nice, like here's the lower bound, here's the upper bound, right? That's all you have to work with, and so it's your job to figure out how to use those. Yeah. All right, so if we're calculating the lower bound and the upper bound, well, it looks like we need our quartiles, right? We definitely need Q1 and Q3. So we need those values, but we also need the interquartile range, which is Q3 minus Q1. So all we need here is our first or third quartiles, and then we'll be able to determine if we have any outliers. So let's have a look at, where was it? That first set of data, I think, at the one that has 10 data points. I know I keep stealing it. Does the first set of data, right, the one including the 100 data point, have any outliers? So here, right? And you don't need to show all this work, right? All you need is that Q1 is 68 and Q3 is 86. Hey, cute. Right. So if we have the quartiles, right? I just stole all that data because I needed to see it, right? And so now I've got Q1, I got Q3, and so I can find the interquartile range, right? And so let's start there. And so the interquartile range is Q3 minus Q1, which is going to be 86 minus 68. 18. So now the rule says, okay, well, 1.5 times that is how far I can go below Q1 and above Q3 before I start having outliers. And the 1.5, there's, I mean, kind of since the start of stats, you know, someone decided, oh, 1.5, yeah, that's a good rule. Oh, well, I came up with this brand new method that uses 2. Oh, okay, crazy, wow. Well, I use 1.7, it's way better. So the 1.5 was just a number that's been decided on. You could use some other value, right? 2, 1.7, 1.9, 1.975. I don't know. You can write a thesis on that, get your PhD and get out of here. No, those days are over, but they did exist at one point. So, right, so things like that. There's kind of been a war going on, but that was a long time ago. Now we've just landed on 1.5, and that's the one that we stick with, right? And so, again, right, in the lab, you saw the box plot, right? And it shows the outliers with little stars. That uses the 1.5 IQR rule. And so that's the most used one that we have. Okay. So if we want the lower bound, let's start there. Well, we said the lower bound is Q1 minus 1.5 times the interquartile range. And so plugging in our values here, our Q1 is 68 minus 1.5 times 18. You definitely could have found the 1.5 times 18 separately and then just plugged it in. As long as you show your work, then I'm happy. So 18 times 1.5 is 27. So 68 minus 27, oops. Thank you. It's 41. So now what we do, kind of incognito here, we go back to our data set just to see any value that's smaller than 41 is considered an outlier. 62 is our smallest value, right? And so there's nothing smaller than that. So there are no outliers on the lower end. Right? And so since the minimum is, what was it, 62? And I'll use a little bit of shorthand here. Since the min is 62, there are no values smaller than 41. There are no values smaller than 41. Therefore, there are no outliers on the lower end. Therefore, there are no outliers on the lower end. How about the upper bound then? Same idea, right? We can find the upper bound. The upper bound is Q3 plus 1.5 times the interquartile range. Q3 was 86. Plus, and I'll show my work again, but if you wanted to just plug in 27, that's fine. 1.5 times 18, which is 86 plus 27. $113. So 113, going back to our data here, we know, or we might remember, right, our largest data point was 100. So by the same kind of argument, there are no outliers on the upper end. Right? if that 100 was changed to 115, for example, then 113, 115 would be on the outside, right? So it would be an outlier. And so since the max is 100, there are no values larger than, oops. Stuck. There are no values larger than 113. Therefore, no outliers on the upper end. On the upper end. Oops. So usually to summarize our data, right, we'll use a 5-number summary, right? So to summarize our data, or I guess it's going to be on a new page anyway. So to summarize our data, we can use a 5-number summary. Our 5-number summary is going to be the minimum, Q1, the median, Q3, and the maximum. So if we just have these values, our minimum, we said in our data set, if we focus on that first one with the 100 included, our minimum was 62, right? And we can just, once we've sorted our data, the easiest ones to fill in is our minimum and our maximum, right? So 62 and up to 100. Our Q1, we decided, was the 68 and then 86. And the median, now I can't remember what the median was, but I've got it right here, 72.5. Using just the 5-number summary, we would be able to tell if there are any outliers, right? You've got your quartiles, you can find your upper and your lower bounds. You won't know how many outliers, right? But if both the minimum and the maximum are inside those bounds, there are no outliers. If one of those is outside, you can say, yes, there are outliers. I don't know how many, right? But we can use the 5-number summary to determine if there are outliers. If there are outliers, right? So even just with a 5-number summary, we don't need the whole data set to be able to say if there's outliers or not. And then this is kind of hard to tell, right? It's hard to kind of think in our minds, oh, the distance between 68 and 72.5, that's less than the distance from 72.5 to 86, right? That's hard for us to do. And so to visualize the 5-number summary, we use a box plot. Okay. And so to visualize the 5-number summary, we use a box plot. Okay. One thing that I do want to go up here and add is the 5-number summary has to be in this order, right? It has to go from smallest to largest. If you're wild and crazy, you could go from the largest to the smallest, but for me, I like starting at the minimum and going to the maximum, right? So they have to be in that order. If you flip them around, that's weird, but I guess it's fine. So must be in this order. And I will take marks off if they're not. Right? Oh, you wouldn't. I would. I wrote it in pink. Must be in this order. I know, the nerve. Okay. And so a box plot is going to look like this. Well, how I like to start kind of in the middle of the page is I draw a box. It's a box plot after all. Okay. The line in the middle here is the median. And usually there's some scale kind of here. Which means that the lower bar here is probably our Q1, right? It's going to be less than the median. And then the upper part of the box, that's our Q3. Okay. And so the box, right, that's our central 50% of our data. Okay. And then we draw what are called whiskers. And so the whiskers start from the center, and then they end at a little bar shorter than the big box, just to make it look nice. And so these are called whiskers. This is a whisker. And they'll end at the minimum, right? Or the smallest value inside the lower bound. I'm not going to show an outlier on the lower end, but I will show an outlier on the upper end. So now, let's do a whisker here. And so this is the largest value inside the upper bound. And then whether you use a star or a dot, doesn't matter. But a star indicates the outlier, right? And so that's using the 1.5 IQR rule. Yeah. So you don't visualize your upper bound? So usually if I'm having to draw a box plot by hand, sometimes what I'll do is I'll draw like a little imaginary line, right? And so this might be my upper bound. And definitely if you're having to draw one on a test, then if you've drawn that invisible line, you should show me that that's what you did, because that's a good thing, right? As Martha always says, it's a good thing. So, right, and so I want to see your thought process there, and that's definitely good, right? Because it's good that you're saying, okay, well, anything past this point, and maybe same idea down here, right? This would be our lower bound. But yeah, so we draw to the values, to the data points, ideally. Right. That's what the software does. Okay. Another option is to draw your box plot something like this. Oops. On its side. This one's sloppy, but whatever. Could also draw something like this. Yeah.
So anything past 113 for that example would be an outlier, so that just identifies what.
That's right.
An outlier past 113.
Yeah.
The same case would be lower.
Exactly. Yeah. So anything beyond those 2 points are outliers. In our case, we didn't have any, right? But if we imagine changing the upper value, the 100 value, let's change it to 10,000, right? Like we did earlier. It's going to make our graph look really weird, right? Because there would be a star right at 10,000, nothing in between, right? And so, but yeah, so you use those bounds to determine, are there outliers, right? And then once we get into comparing groups of data, right, then we're going to make side-by-side box plots to visualize just what do these differences look like. We compare groups of data using side-by-side box plots. Which might look something like this. Just drawing little box plots here. Imagine them being just as wide as each other, but I'm just sketching them here. All right, we've got a couple of different options. So here, side-by-side box plots, right, help us see, okay, well, the first group is kind of middle of the road. The second group is nice and tight, but all down here, right? And then the second group has a huge spread, right, with an outlier and weird things. But it looks like the top 50 or the middle 50% of our data is higher than all of the other data points in the other data sets. So things like that. So we'll be able to compare the groups easily by using side-by-side box plots. Okay. I did not get as far as I had hoped, but that's all right. Now we're done chapter 2. There's a lot in there. I don't know. So next day we'll start chapter 3. There's no point in starting now. Any questions though? Yeah. Yeah, so for next day, next day we'll do as much of chapter 3 as possible. That helps. Because we're supposed to finish chapter 3 this week. I think we can still do it, but it might be a little bit of a stretch. I do have typed up notes that I might bring, so let's see. Cool. All right. Bye, guys.